Aduh, I'm exhausted. Hey, Aziz, how many kilometer did we run today?
Wait, let me check. We got about 3.3 kilometers.
How about you, sir?
Mine says we have run about 2.9 kilometers. How about you, sir?
Oh, I got 3.0 kilometer. Why so different,
Yeah, each of us gets a different Strava. If only there's a way that we can find the exact diameter of this lake. I think we can calculate the exact value of diameter of the lake of this lake like this.
Good morning everyone and thank you for your time. My name is Daniel and alongside my teammates, we are presenting our MAT 575 project. So, our study focus on section 7 Lake Inshallah, while many of us know it as a peaceful recreational area for jogging and relaxing. So, it also plays an important role in our local ecosystem. So, for this project, we want to see how mathematical concepts apply to real world environment by studying the lake precise shape and boundary using coordinate data and graphical method. As for our objective part, first, we want to estimate the curve and boundary of the lake using mathematical interpolation. Second, to calculate its approximate arc length using distance formula alongside degree 2 and degree 3 polynomial functions. And for the third one, we want to calculate the absolute and relative error of this model against true reference of value of 24. And finally, to compare this error to determine which polynomial degree is the most effective at accurately capturing complex graphical data. With that, I will now pass the floor to the next presenter to discuss our data mapping.
Hello, my name is Hafizul Asri bin Shamsun and I will explain the graph for our project about the lake at section 7 Shah Alam. This graph shows 12 coordinates points that represent the boundary of the lake. The x-axis represents the horizontal position, while the y-axis represents the vertical position of each point. All the plotted points are connected to form the outline of the lake. Based on the graph, the lake has an irregular curve shape. The highest point of the graph is around coordinate 7.6, while the boundary extends to approximately x equals to 9.9 on the right side. This graph helps us visualize the actual shape of the lake and provides the data needed for the further mathematical analysis.
My name is Muhammad Firdaus Wafi bin Saluddin. Our methodology is divided into 3 consecutive stages to ensure precision. First, we establish a discrete baseline boundary of the riverbed by applying the distance formula between each collected coordinate point. We calculate the exact value of x, which yield a total sum of 31.2581. Second, because a real riverbed consists of natural smooth curve rather than rigid straight lines, we utilize forward difference to construct a divided difference table. This allows us to perform quadratic interpolation for all 4 sections of the river profile. By integrating the resulting derivation function, we successfully compute a highly accurate total arc length of 38.6571 cm.
My name is Diza Shahmi Bezaidi and I will be presenting about interpolation formula of the degree G. We can now use the Newton forward divided difference interpolation formula of the degree 3 for each of the section, for the section A, B, C and D. And then after applying the formulas, the result from the interpolation formula will then be used in order to obtain the arc length, which is to obtain the distance along the curve of each section. And then finally, the answer for each of the arc lengths will then be total up. And the final answer for the total up will be considered as the new approximate value of the parameter of the lake.
My name is Muhammad Aziz Zaid bin Amiruddin. To understand why this error occurs, we have to look at the lake actual geography. The distance formula and the degree 2 polynomial have much higher errors because they are mathematically too rigid. A degree 2 equation essentially just gives a simple parabola, which cannot accurately capture the irregular borders of a natural body of water.
However, the degree 3 polynomial introduced an inflection point. This extra mathematically flexibility allowed the model to easily trace the less complex natural contrast, which is exactly why our error dropped down to outstanding 2.65%. Finally, here on our last slide are the references we had used for our modeling and research. This concludes our analysis of the Section 7 leg.
So that's how we get the exact value of calculation of diameter of the lake. So let's jog again at this lake.
Next.
Let's go.